So, how's everyone? You okay? This is a stunning room. I mean, I'm really glad that we've got this room for this talk. Hope you like it as well. Hope you don't get distracted too much. Basically, what I'd like to talk to you about is multi-factor authentication solutions. So it's not the enterprisey stuff. It's what you come across online, what you come across when you access your Gmail, your iCloud account, and so on. How many of you have done any research on multi-factor authentication? Cool. A couple of hands. Yeah, there's some research out there. There's not huge lots, obviously, and that's partly because, in my view, there's fewer services that offer two-factor authentication than there should be, but we'll get onto that a bit later. The primary focus is on typical implementation flaws. Let me know in the back if you can't hear me. I'll try and speak a bit louder. And I'm also going to try and point out that it often takes a bit more than just sticking an SMS prompt in front of your web server or a Google Authenticator on your website to actually come up with a real proper multi-factor authentication solution. I'm a little bit about myself, just very briefly. I'm Boglarka Ronto. I work for Commission. I'm head of testing. I've been working there for 5 years, and that means I get to do some of the more awkward stuff, some of the testings out of the ordinary, so I'm quite happy with that. A couple of words on responsible disclosure. This is because I had to anonymize a part of the stuff that's in this talk, not because the vendor didn't fix the issues. To my understanding, they did, and they've implemented countermeasures, but they still preferred not to be named. So, but this is still sufficient for us to have a look at the typical issues, and also to come away with a couple of conclusions on what not to do and what to look out for in the future if you want to advise someone on multi-factor authentication, or if you try to implement it yourself. So just very briefly, you probably all know what multi-factor authentication is about. So it's effectively trying to choose two or more factors so that the user would have to know something like their passwords or PIN codes. They would have to possess something like a token, or in the case of a bank card, they have to have the physical card itself. And the third factor is inherence, which means that they have to be something. They have to it's typically associated with biometric credentials, and they have to have some sort of equality and to be able to get through the authentication process. You probably noticed that I'm switching between two-factor authentication and multi-factor authentication. That's because multi-factor authentication is a more proper way of talking about this topic. Two-factor assumes that you're only using two of these three. Multi-factor assumes that you're either using three or potentially more of these factors to process your authentication. So there's not a huge load of information here. You probably all knew about this already. The most common way of implementing multi-factor authentication is using tokens. We've got loads of soft tokens now. We've got apps. We've got just console stuff. We've got Radius. We've got so many solutions that support this, and we've got hardware tokens as well. They're a bit dated now, and obviously there's an issue associated with hardware tokens that if you collect a lot of them, then you'll end up with a big thing to carry around in your pocket. So most of the companies are actually transitioning to soft tokens, and I used to always think that these soft tokens were like magic. 10 years ago when they introduced RSA Secure ID tokens, they magically allowed me to log into to authenticate to my Kerberos server with it being completely disconnected from every network. And I thought that there's some brilliant engineering going around in the background and lots of convoluted algorithms, but it turns out that's not really the case. It's actually quite simple. We'll just get on to it in the next slide. And the only standard that I'm aware of that actually requires users to do multi-factor authentication is PCI DSS. But I suppose it's something. So this is how it all works. Again, very briefly, if any of you is interested in the algorithms, you'll probably look it up. There's two main ways of implementing multi-factor authentication. One is HMAC based, which is the top one, and also this yellow column here. And all that uses is a counter, an incrementing counter, and a shared secret, which is then hashed and combined with the counter to produce a one-time pass. Every time you press the button, counter is incremented and you get a new token, so there's no time factor involved. As opposed to the second one, which is time-based OTP, where you have, again, a shared secret, but instead of the counter, you have a timestamp that is always synchronized. So that's why sometimes if you travel overseas, your tokens might get out of sync, or you might not be able to use them, especially if they're soft tokens, because you then switch time zones automatically. So the shared secret is when you're setting up two-factor authentication, you normally get a QR code to read a QR code on from your laptop screen and put it in your app. That's actually the shared secret. So if you ever want to look at it, it's typically 10, 12 digits combination of numbers and letters, and that's all it is about. What I want to talk about next is a couple of the most prominent examples of where multi-factor authentication hasn't been implemented very well, owing to a number of reasons. So we had the Apple iCloud incident in 2014, which was really about not having all of the areas covered with the multi-factor authentication. So they enabled it on a couple of services, which you can see there. Like, for example, typically the services that would be associated with credit card payment, because that's what they thought would be the most valuable targets for an attacker. But at the same time, they didn't enable it for things like syncing your photos or bookmarks, which is also sensitive. And on top of this, they didn't really tell the user that this is going to be the case. So they automatically assumed that when they enabled this added level of security, they were protected, but that wasn't entirely the case, because their photos and bookmarks could still be synced. And in addition to all of this, they didn't email users when a new untrusted computer was set up for this sync. So that wasn't really a good example of how you would go about this sort of thing. The next one, again from 2014, this is associated with PayPal and the linking of eBay accounts to PayPal accounts. So what happened was, you can see that integrated registration area there, the one that is highlighted. Unfortunately, I don't have a laser pointer, but it shouldn't be too difficult to spot the area. Effectively, that's just a token. So it's part of the URL. It doesn't have a value, it's just a flag. So when you were visiting PayPal, transitioning from an eBay site, you got that additional flag in your URL, so that when you logged into PayPal, you weren't prompted for a multi-factor. You just had to put in your username and password. And this guy discovered it. It was I think a 17-year-old that if you if you just insert this token, even if you log into PayPal without having anything to do with eBay altogether, you would still not be prompted for two-factor authentication. So it was an effective way of bypassing it. Fortunately, they've moved on and corrected that quite quickly. And then this is a bit more interesting. LastPass. Two Spaniards, they did some research, and they also presented their talk at Black Hat, I think, in 2015. And they basically tried accessing the encrypted vault of LastPass. It's a password manager. You're probably familiar with it. Effectively, it allows you to sync your database password between hosts, and also to store it in the cloud, but without them actually having access to the data. So what they did was, they were looking at ways of accessing that encrypted vault along with the master password, so that they could look at the contents. And they found that there's this account recovery mechanism that is not entirely in line with what you would normally assume best practice. So once you initiate an account recovery, you got a unique URL, which you can see at the bottom, and you didn't even have to change your existing password. You could just continue with whatever password you had, as long as you had that link. So that allowed them to recover the encrypted vault and bypass multi-factor authentication, because even though that was enabled on the site, as long as you had the URL, you could just access it. And on top of all of this, they found out the algorithm used to compile those URLs. So even if you didn't initiate an account recovery process, you could still forge a URL and you could access someone else's encrypted vault. So that was a big thing, and fortunately they've also fixed this, so that shouldn't be the case. And then now PayPal again. You would really think that if someone's burdened themselves, they would try to make sure that it doesn't happen again. Well, it did, and the way they did it this time was PayPal actually had a preview portal, and when you access the preview portal, you weren't prompted for multi-factor, but when you access the normal PayPal, you were. So you open the normal PayPal site, then on a different tab you open the preview page, logged in there, and when you went back and refreshed the normal PayPal page, you would just be thrown into a valid session because you already had a live session in the preview page. Funny thing. So it's not even worth a screenshot because it's so basic. And our favorite, Outlook. How many Outlook users? Yeah, a couple. So this one, from all aspects, Microsoft multi-factor authentication is amongst the better ones. But a couple of researchers discovered that there is actually an Exchange web service that doesn't require multi-factor authentication, and it's enabled by default. So when a company installs an Exchange server and they publish it online, you'll get this Exchange web service in addition to your OWA, which is the Outlook Web Access. And if you don't disable it explicitly, someone's going to be able to access email belonging to an account without actually having to go through the multi-factor authentication part. And this is interesting when you're doing, if you're doing an internal pen test and you get hold of a couple of domain accounts and you then visit Outlook Web Access, but they use multi-factor authentication. There's a script on GitHub that these guys made available that actually helps you out, and you can use it to retrieve email and retrieve other information from this person's account. So unfortunately in Microsoft View this is not a bug, it's a feature. So the only way you can really protect yourself against it is to disable Exchange Web Service. And to sum this up, the typical implementation flaws, some of the features are not covered. So you have a set of features or a set of ways to interact with the service, like in the case of Apple, and not the entire scope of your organization or your services provided is covered. So that means that some areas are going to be okay, but your users might be living in a belief of false sense of security because their accounts could still be accessed potentially through different channels. And there's the matter of integration and federation, which we saw with PayPal in two instances as well. Whenever you're implementing integration, you need to really think about whether there's a development area or a preview area that isn't at the same level of security as your production environment. And then there's obviously the lifetime of these tokens, like in the case of LastPass, where these URLs could be forged and they were not really bound with any time barriers, so you could access it over an extensive period of time. And finally, you could also mention poorly implemented account recovery mechanisms and just features. So this is the actual stuff that we've done, and this is the part where the disclaimer from the beginning of the talk comes in. All of this is anonymized, so unfortunately I can't disclose the name of the provider or the vendor, but we should still be able to look at the flaws in their mechanism. This was a custom implementation of a custom approach to multi-factor authentication, and their aim was to create an authentication mechanism whereby you have a username and you have a pre-registered your phone number is registered offline with the organization, so you don't have any facilities to register yourself or to change your phone number, and you'd be prompted for your username, and then once you've put that in the next stage you'd get an SMS message with a code that you would need to also provide, after which you'd be transferred to a secondary server, and that secondary server would have the actual application that you wanted to access. So in this case, it was an instance of Citrix Synapse, and they opted in for this sort of solution. At least I think the reason why this happened was that they didn't want any form of interaction with that secondary server, because normally you would have built-in capabilities in Citrix for integrating it with the multi-factor providers, but in this case they chose a very different path. And so this was the initial login screen. That's my user ID, and in the next step you actually were prompted for the password. So this is the code, and the very first thing that immediately occurs to you is that this doesn't seem to be like a regular password prompt, does it? I mean, it's not obfuscated in any way. It's just a plain pop-up window with where you can put in your details. So this was the first telltale sign, but there were many more to come. Anyway, once you've gone through all of these steps, you reach the Citrix receiver, and you're supposed to log in with your additional domain username and password. But I'm not going to go into that because that's not really in scope of this talk, and also really what we're interested in is the mechanism beforehand. The site also set a cookie, so I'm going to start going into the technical details of it. I'm going to try and keep it high level, but still, those of you who know JavaScript and who want to read this, hopefully you can still see it from the back rows. So all of that going through the initial authentication process. We looked at the website, the page that was downloaded on in our browsers, obviously, and there was a bit of JavaScript code in there, which was this bit. So basically, what it says is that it prompts you for the username and password. Yes. If you don't put in something or you cancel it, it just automatically throws you onto an access denied web page. Once you've managed to put your username in, it sends you through to the next URL, which is this Python code here. We didn't manage to get access to this file, so we don't actually know what's in the script, but we know that it's calling a binary, a Python function that would actually, with your username, that would actually trigger the SMS to be sent to your phone. We didn't have control over our phone number. It was provided to the provider before the testing started, so we had to rely on getting that text message. And if anything went wrong, we just got to an access denied page. So this is the actual HTTP GET that was sent to the server. All of the communication, this is another potentially unusual way of implementing this sort of thing. Every bit of communication was sent to the server using HTTP GET requests. There were no posts whatsoever, so all of the information was always in the URL. And I just highlighted this piece of information so that you can see the Python code and the username being submitted. Next is the response from the web server, which is in this case a HTTP 200, which means okay, the request was received. And we got access to a transaction ID, which is going to be used later on in the communication. But at this stage, it seemed that the secondary server, the Citrix box, couldn't be accessed without this unique transaction ID, which was actually received from the server after the username has been provided. There was no ping so far, so that will be the next bit. So then, once we sent the username and we got an OK back, so effectively if the username was wrong, we would have gotten an access denied. Next stage is that the script requested us for a pin code. So we provided what we got in the text, and then what happened was that it submitted that transaction ID along with the pin back to the server to a second Python script, and then that returned either an OK or an access denied. depending on whether your code was validated correctly or not. And in the next stage, you can see that there's something very awkward going on here, because in the next stage, as you go along with the JavaScript, it's actually the JavaScript code itself that validates this transaction. So we get a response back from the server, and then the JavaScript checks that status and then tells us whether we're okay or not. So who's the first person that is going to tell me what's wrong with this?
It's validate stuff on the client side.
Exactly. So it's all validated on the client end. So we can pretty much do whatever we want with this, yeah? Definitely. So, but let's play along. We went then and submitted the transaction ID, which is P1, and the pin code, which is P2, and then this is the GET request that was sent to the server, and this is the code that we got back, and as you can see, it's just an OK. So this is there was one additional bit that I haven't mentioned before, and if we ever got an OK message back from the server, we actually the JavaScript code set a cookie in our web browser. So this was not received from the server. This was set by the JavaScript code, and so you wouldn't normally get you wouldn't see a set cookie directive as you would if you're doing web application testing and capturing the traffic using a proxy, because this would never be seen by the proxy. It's just purely JavaScript doing its thing and setting this cookie in the browser. So what do we do about this? So we looked at ways of how to bypass this, because there's obviously something very wrong with this implementation. First, as you mentioned, there's client-side code, but then there's also the validation mechanism that isn't really right there where it should be. So initially, we started forging the cookie. So it seems like, because we have the JavaScript code, we have exact piece of code that actually created the cookie. We just forged the cookie and checked if we can access the secondary server, the Citrix box. We did. It worked. So next, we tried to see if it was possible to manipulate HTTP responses from the server, because it's a relatively simple way of telling JavaScript of lying to JavaScript. And this is the part where it's validated, so it's trivial to modify this, and of course it worked. And next we just looked at whether we could just always tell the JavaScript that whatever it got, whatever response it got from the server, let's just say it wasn't okay. Yeah, of course it worked. And so finally, when we were really lazy about this, we just said, okay, let's capture the response from the web server, not the request, and just say it wasn't okay instead of 403, and of course it worked. So at that stage, we effectively established that the secondary web server, which was the Citrix box, could be accessed just by either forging the cookie or letting the JavaScript doing its work by modifying the response received from the server, which also meant that neither the pin code that we initially used to verify ourselves nor the transaction ID were necessary to actually access the Citrix box. And the main reason the main reasons that made this attack possible were client-side code. It's really dangerous, but if you look at various other areas where they're using implementations of multi-factor, it's not actually that uncommon. If you think about your bank card, when you put it in an ATM, it validates your PIN code, but that PIN code is actually stored on the card locally, and the agent that validates it is the ATM machine itself. So it's not unusual to have client-side validation of some form of input. It's just that in case of an ATM, you're much less likely to be able to tamper with that information, as in the case of a website where you have complete control over whatever happens at the client end. So the other problem was that the server actually didn't require a form of validation. So it did validate our PIN code, but it didn't. This wasn't enforced in any way. So we could do whatever we wanted, regardless of whether we got an OK or a not OK from the server. So that validation mechanism really should have been a lot more robust to be able to handle instances where we were trying to forge messages. And finally, the value of the cookie, which really should have been something unique, was quite predictable. In fact, it was just 300 seconds added to the current timestamp, which is a 5-minute interval, and it's trivial to forge it. It's very, very poor security practice to use predictable cookies anywhere in relation with web applications. So I then thought, why don't I look at some of the other implementations of multi-factor, ones that are closer and more accessible to people. And I looked at Google's Authenticator, which is one of the better ones. So it's not all doom and gloom. There's good examples of implementations of multi-factor out there. And Authenticator is an open source piece of software, so hundreds of developers have validated it already, and it's reasonably well implemented in terms of supporting channels that don't otherwise support multi-factor authentication. So you can create one-time passwords that you feed into your IRC client or binary email client or whatever, and you can use it to sort of skip OTP or multi-factor authentication for that one particular service, but that's a code that you can only use once, and then the next time you disable that service or log out of it, you would have to create another one-time password. And they also use this for file synchronization and some other areas, and this is actually a relatively good implementation. So the next one is Office 365, which is again quite good. It's got very good integration with lots of services provided by Microsoft, and you would expect that because it's their product in some regard. They use this MS Authenticator app, and the principle is the same. You can either use TOTP or HMAC-based OTP, and you're basically prompted for a key or an OK before you access a service. The one weak area of this implementation is, as well as the Google one, is that you can bypass this if you choose to receive a text or a call. And sometimes you can, within certain environments, like where your coverage isn't great, you might be able to access someone else's voicemail because you just tried authenticating with their account and diverting their call. It's not very likely, but there's ways of trying to do this, but that's not entirely in the scope of my talk. So Microsoft also have things like, especially in the enterprise version of Office 365, they have access to files through SharePoint and WebDAV, which is done through WebDAV, and also OneDrive. And that's got another interesting weakness, whereby the way of actually authenticating to that service is through a cookie, but that cookie can only be retrieved through an ActiveX plugin, which only works in Internet Explorer. So it's sort of a bit of a hack from Microsoft's part, but they still call it a feature. Next one is Steam. This service, they use it's a very custom implementation of multi-factor authentication. As you can see, it's not digits, it's not numeric codes. It's a combination of numerics and characters, and you're almost like you have this enabled from the very start that you register the service, because you keep getting these emails with the codes and you're prompted to enter these codes before you're allowed to log in. Now, obviously, the fact that you're prompted for email as multi-factor isn't ideal, because typically, as you can see on this, that's a screenshot of my Android phone. I am accessing the service from the same platform where I'm receiving these tokens. So it's not really multi-factor because you've got access from the same platform to the same pieces of information. So if someone's got your phone and someone knows your account details, then that wouldn't help. While if it was a true two-factor or multi-factor authentication, then you would use a separate platform for authentication and a separate platform for your token code. It has got its own authenticator app, so it's completely different from the one that I've showed you from Google or from Microsoft. And then there's Blizzard, and these guys like to live dangerously. So they use this, again, it's a custom implementation of their app, and you have to use this to log into your Battle.net account. And those of you familiar with them into gaming will know this. And yes, the code expires, so it's relatively, on the face of it, it's relatively good. But when you start digging into it, then you come across the interesting stuff. And initially they also send codes via email, but, and this is the interesting stuff, the Authenticator app, which is with the, which is in the background now, as long as you have it in the foreground on your phone, and as long as it's displaying that code, if you look at the actual communication between your phone and their server, you'll see that it's just sending these codes every half a second, and it just keeps sending them. So it's almost like your code isn't really a secret anymore because it's submitting it to an API, and it's almost like it's not broadcast, but it's running through a network, and it continuously does this regardless of what you're doing. And the even more interesting thing is that under certain circumstances, you can actually trigger that to happen over plaintext HTTP. So normally it goes through HTTPS, but sometimes it doesn't. And there's the two instances there are highlighted. So that means if someone is listening on your network, you're sitting in a coffee shop or maybe even at home, and someone's listening to traffic, they'll get access to your code. And that's not really what you would call best practice. So this is one of the reasons why soft tokens can be problematic. So you really have to make sure that you've covered all ground before you release a piece of software that does this for you. So this isn't entirely my opinion. You may have a different view on it, but I thought I'd share it with you in case you have something to add or discuss about it. As I mentioned in the first part of my talk, there's some research on multi-factor, but there's not a huge lot. And that's because we don't use multi-factor authentication enough. We don't use it, we don't have it on our council login pages, we don't have multi-factor on our utilities providers or our streaming providers or telecoms, even though some of the telecoms organizations do encourage you to use the email accounts provided by them as your personal primary email account. But they don't provide MFA. And yes, this solution isn't for everyone, but to have that as an option would enable certain users to be more secure and reduce their own attackers and protect their accounts. And the other reason why I don't think there's enough research done in this field is because, as you can see, there are problems. So there's stuff to research, but people just tend to trust multi-factor authentication because it's in addition to what you normally have as your username and password. So if you're accessing a website that's got HTTPS on it, it's got a big green certificate telling you that it's safe to proceed, and you've even turned on multi-factor authentication, you think you're brilliantly safe, but sometimes that might not be the case. And we should trust and fail a little bit less and do more research to uncover those really problematic areas. And so it doesn't necessarily mean that if you've implemented multi-factor, you're all protected, and that's the only thing that you had to do, and you don't really have to take care of the services anymore. So it shouldn't be a tick in the box. And the typical reasons why people don't do this is Well, they say it's expensive and difficult to implement, but you'll definitely find expensive vendors and expensive providers for multi-factor authentication, but you'll also find free software like the Google Authenticator, and you'll find open source solutions, and you'll find not so expensive but still third-party solutions that will give you some level of assurance. And there's also a saying of some people say that this is not for everyone. Yes, that's true, but I don't think that the entire user base should be qualified by this, because it isn't going to be confusing or complicated for everyone. For example, I've gone through a couple of large providers like Apple and Microsoft and Google. How many of you have Apple iCloud accounts? Yeah? How many of you use Microsoft, Xbox, Hotmail, Outlook.com? Fewer. And how many of you use Android or Google? Yeah, quite a bit. So by this time, probably most of you have put your hands up at least once. And it's not only these providers, there's the gaming providers, and there's a lot of other services out there that already use multi-factor. So the majority of the user base would have encountered this one way or another, so it really shouldn't be that confusing or complicated. It's something that can be made easy, and there's good examples of that being done. So in my view, again, this is just my view, these are excuses. And I've mentioned Google and Microsoft and Apple as well. So that really takes me to the end of this, and I'd like to talk to you about this, or I'd like to hear if you've got any questions on this topic. It's something that I think we should discuss. So,
Thank you.
Now you talk about Blizzard, and you said that you triggered it to get a HTTP.
yeah.
How did you do that?
Could you just repeat the question so I was the microphone?
Absolutely. So the question was that there was this example about Battle.net, and there were a couple of queries that went through in plain text. It was actually I was actually trying to force HTTP transactions. Although, if you go back, maybe I should probably go back to that slide. There's you can actually see that this cookie is both secure and HTTP only, which normally means that secure cookies wouldn't be submitted through HTTPS. And if you've got the HTTP only flag, then you can't read the cookie's value from JavaScript. But this shouldn't be capitalized. And as I was trying to force HTTP traffic, some of them have gone through. This was a load balance solution, the API at their end, and my guess is, I couldn't verify this because it was a little bit unpredictable. Some of the load balancers might not be configured to the same standard as the others, and some of them just let the HTTP bounce back because there's alternating requests, so some of them go to eu.battle.net, and some of them just go to Battle.net. And the sequence of the submission is that you first send the token to Battle.net, and then that triggers a response, and you get another submission towards the other URL. And you don't really have control over what happens there. So when you try to forge it, you forge this bit, this request, and then you may get an HTTP response back, because that's that is triggered by the refer, which you can't see here unfortunately on this screenshot. But it's if you try to force this second request to be HTTP, it will just tell you to go away.
Was this getting the code from them, or was this submitting your code?
This is what the authenticator keeps submitting. So it goes on and on. So it's just happening in the background as you've got this counter, and as this code is being displayed on the screen, this same code is being submitted at the back end twice a second towards the API.
Right.
So you keep submitting this, and then you trigger one of the transactions to be HTTP, you force it, and then the next one would suddenly be HTTP.
So you're saying that sometimes it just randomly will send it over HTTP?
Well, you have to try and trigger it, but yes, sometimes
When
it
you say
will work.
trigger it, were you like blocking port 443 from?
No, their servers actually have both 443 and 80 open. And what I'm doing was, I'm using this tool called burp proxy. I'm sorry, by the way. So with burp, you have the opportunity to try and strip the SSL layer. So when you're capturing the traffic, you've got the opportunity to it's like a time lapse, and you press pause. And whenever you press pause, you can then edit and modify that package, that query, and then submit it or forward it.
Right.
And then you change that piece of package, the information in it, from HTTPS to HTTP and redirect the port from 443 to
So the app
80.
itself wasn't sending it from HTTP?
Yes. Yeah.
So there'd be no way of being able to get someone to use HTTP then, unless you're on burp, really. Is that right?
There are other SSL stripper solutions as well, and you would have to try and somehow actively interact with the traffic, I think. You could, for example, try and write a script for Ethereal, or you can try other types of man-in-the-middle attacks, but you would probably have to somehow try and tinker with the traffic flow.
Any other questions?
If you looked at the, because Google have changed it now, so when I log in, instead of using Google Authenticator, I've just got a push notification. Have you looked at that at all, or any of the FIDO implementations?
No, that wasn't. I didn't have time to look at that, unfortunately. But it would be an interesting thing to look at, as well as some of the enterprise implementations like Swivel and Duo, where you've got in like a box sitting on premises that integrates with some of the services. And I'm pretty sure that there are going to be areas that aren't going to be protected as well as they should be. So there's always a risk of that.
No, I mean, I've implemented RSA boxes and we were just really bad at it because we were lazy, so we just install it and walk away. So it's like a low bouncy, it does 100 things, you do one right, so yeah, they'll be full of holes because of me and my colleagues.
Well, at least you've admitted to it, which is the first
Yeah,
step. Okay.
Anyone else got time? No? Okay, well, coffee's downstairs in 15 minutes, I think, and the next presentation's here at 4 o'clock. Can I thank you?